Hey everyone, welcome to today's video where we're going to tackle a fascinating problem that some of you might have encountered while working with Excel. So, let's dive right into the problem, shall we? Now, let's talk about the solution to the problem we just discussed. When we look at the representation of a number on 32 bits, the bits are arranged from B31 all the way to B0. This setup allows us to represent numbers in a binary format, which is essential for understanding the issue at hand. Continuing with our solution, let's delve into the numerical representation of the number using the formula 2 to the power of 31 plus 2 to the power of 30 plus 2 to the power of 0. This representation showcases how each bit contributes to the overall value of the number, giving us a deeper insight into the binary structure of the integer. Moving forward with our exploration of a solution, let's focus on the binary representation of the number 214-748-3647. By breaking down the binary sequence of this number, we can better understand its composition and how each bit influences the final value, shedding light on the inner workings of binary arithmetic. Now let's shift our attention to the binary representation of the number 10000000000000000000. By analyzing this binary sequence, we uncover how adding 1 to the largest positive number on a finite number of bits results in a negative number due to the overflow in binary arithmetic. In conclusion, we've unraveled the intricacies of binary representation and explored how numeric values are interpreted in a 32-bit system. I hope you found this journey into the world of binary arithmetic both enlightening and entertaining. Remember to like, subscribe, and leave a comment below with your thoughts. Until next time, happy calculating!